Okay, if you notice that these equations are getting more and more complicated, we're still trying to get what x and y are, but we cannot use substitution because it would take too long to isolate x or y in either one of the equations. We cannot eliminate 3x and 2x to get rid of x, or 4y and negative 3y. So what we're going to do is multiply the top and the bottom by some number in order to get rid of the x or the y. If you notice in this equation, 6 can go into 3 and 2, so if we multiply the top by 2 and the bottom by negative 3, we could cancel out the x's. Or we could multiply the top by 3 and the bottom by 4 to eliminate the y's. There are two choices. So once again, you can multiply the top by 2 and the bottom by negative 3 to make this a positive 6x and a negative 6x. That's one method. Or if you want to eliminate the y, you can multiply the top by 3 and the bottom by a positive 4, since this is already a negative 3, so that it will be 12y and a negative 12y to cancel out. So let's go ahead and use this method right here. And go ahead and use your distributive property. So 3 times 3x is 9x. 3 times 4y is 12y. And negative 25 times 3 is negative 75. Again, distributive property, 4 times 2x is 8x, plus, and then I'm just going to write a negative 12y here, and then we have 24. So our goal was accomplished. We were able to convert 4y and negative 3y into a positive 12y and a negative 12y in order to cancel this variable out. And then it becomes just like our normal problems from earlier on. 8 and 9x is 17x equals to negative 51, a negative plus a positive, negative 75 plus positive 24. Then we're going to go ahead and divide both sides by 17. You can always do the work on the side. 51 divided by 17 is a negative 3. Plug that into either equation to get your y. I'm going to plug it into this original problem here. 2 times x is now negative 3 minus 3y equals to 6. Go ahead and solve for this. This should feel very familiar. We've done several of these types of problems already. Go ahead and add 6 to both sides. Negative 3y equals to 12. Divide both sides by negative 3. We get y equals to negative 4. So your answer, final answer, is negative 3, negative 4. Okay. So what was confusing about this problem was we weren't able to eliminate any of the variables unless we manipulated the first equation and the second equation to have a common number, but the inverse of each other. A negative 12y and a positive 12y cancels out. Okay.